I'm excited somewhat to get off campus to go to bed.
Yeah. Yeah.
Yeah.
And so that's the problem with this, I think, is maybe if we set a different time, but whenever we do this, I'm so burnt from the rest of the day that I don't know. I just want to be done. I don't know. It's like, see. Yeah. All right. Um, so for part one, the sampling distribution is the set of all possible values of x that could occur.
It's all possible sample means. So yeah, x and means are the same from a population.
Yeah, x with the bar over it is mean, right?
Yeah, you got that right.
Is it population mean or is it sample mean?
Sample means from a population.
So x is sample. Okay. X is sample mean. Okay. And then 2 is a normal distribution or a bell curve.
Yep, it would be normal.
And 3 is approximately a bell curve.
Yeah.
Or a normal distribution. And then I just wrote bell, or approximately bell, and then I wrote becomes more like a bell. And then, but I wrote down these two things that they noted from the answer key, that the mean is unchanged, which is interesting. And if you added like 100,000, 100,000, 100,000 on the applet, it was really cool to see the mean. I mean, it might change like a tenth, but barely at all. It's almost exactly the same. And then the standard deviation decreases, which I thought was really interesting, and I don't understand fully. It makes sense, I think, maybe. Actually, no, I don't understand it. I think I might have to ask him about that. Or
yeah,
you.
that would be a good idea to ask instructors, like not divine, say ultimate, say so to speak. So that way, like we go into the authority, use someone to say and just getting the answer for that.
Yeah, makes sense.
Yeah.
So,
how does the shape of the sampling distribution of the sample mean change when the sample size is increased? Did you get that one?
Didn't we just say that? It becomes more like a bell with the mean unchanged in the standard deviation.
Yeah, the mean is unchanged from what I'm looking at. And what is the difference between the central limit theorem and the law of large numbers? Now, when I watched the law of large numbers, I kind of got it as if you get more numbers, you have less of a chance of screwing something up, type of deal. Like if you go and survey a bunch of people about certain things, you're more likely to get a more positive or more against depending on which culture you went into, depending on like how many people you actually surveyed. If that makes sense.
Yeah, it does. It says, you all right there?
Yeah, I'm just developing something. Hopefully it goes away. I just have to do stuff for it.
Yeah. Do you... What was I about to say? It seems like it seemed like one of the keys for the large numbers, law of large numbers, was that it's more accurate, and that was the focus. That the larger the sample size, the smaller the standard deviation, and the more accurate your analysis will be.
Yeah.
And then the other one, the central limit theorem, says that the distribution of the sample of means becomes more normal. It feels kind of like saying the same thing in a different way, but I suppose it's. They said that it's a pretty critical difference, and I want to understand that better. I get that the one is more accurate, and the other one, I guess they're not the same thing, but they go hand in hand.
Yeah. Okay, let's see if I understood this correctly, and hopefully the professor watches this part and to correct me just in case I'm wrong.
Okay.
So the central limit theorem, like it makes more of the bell-shaped curve, but with the law of large numbers, you have, let's say, you interview one person and they're for or against something. But the more people you interview, like the higher you process the interview, the number of for or against goes down and decreases, and it becomes more skewed.
No, the more what it is the more you interview, the more your sample mean reflects the opinion or the mean of the general population. So the more people you interview, the more your sample mean actually reflects
accurate it gets. Yeah.
The opinion of the people. Which would be an interesting. It would be an interesting. I mean, the bell shape or the normal distribution. What do you do? So if I say it's a custom on this applet, but I only have two options. Let me share screen right now. There's only two options like I've set right here, so roughly 15 and 16. It's not. I mean, can you call that a bell curve?
Yeah. Go to let's see. Click on the fit normal. That's underneath the N25.
Look under what?
Look under the N25 on your distribution of means, and it has fit normal. Click on the box next to it.
Yeah, and you get that little cone thing.
Yeah, it looks like that.
So that's the normal distribution, that cone thing?
Yeah, looks like it. At least to my understanding. It could be off. But it could be right on, so who knows? The teacher does, that's for sure.
Well, it does. So because that cone thing fits inside the curve, it's a normal distribution. Is that what you're saying?
Yeah, I think so. Yeah. Let's see. Okay. So go to that. So go to that same screen, yeah, and go to no. Yep. All right. So go to not custom, but click on the normal. Yeah, normal. And then mean of n equals 2, whatever. Fit normal, and you got the same bell curve.
N equals 2?
Well, I just have a different format.
Oh.
Yes, and then I just did animate or whatever.
N equals 2, it means what?
I don't know.
It's a sample size. It's a sample, right? It's your population size.
Okay, so it's not that whole animated thing. It's just.
So if N equals 25. Oops. Yeah, it's the sample size. N is the sample size. And then it takes the mean from that sample size. Mean from that sample. Okay. Okay, should we move on to the next part?
Sure.
Okay, so the X bar or
Yeah.
the
The X bar normally distributed. When is X bar normally distributed?
what's X bar?
Let's see if I understand it.
Is X bar the um, let's see. What is X bar normal? Many observations. Okay, X bar is the distribution of sample means.
Yeah. Okay. Distribute.
How many observations are required so that the answer is it depends, huh?
Yeah.
I'm sure that the distribution of sample means. If the parent is normal, then the sampling distribution of X will always be normally distributed, no matter how many observations are selected. If the parent is not normal, then the sampling distribution X will be approximately normally distributed, if the sample size is large enough. That's bizarre. Why is that the case? Because if the parent is not normal, the larger the sampling size uh, is, the more it reflects the parent population. So if the parent isn't normal, let's say it's right skewed, um, then wouldn't a larger sample size reflect uh, also have a right skew? Would be more likely to have a right skewed population.
Interesting. Do you think when they say normal, they're talking about the slant is consistent? Like it makes something like that with a more even curve or whatever, even slant. I wonder if that they're talking about like normal like that. You get what I'm saying?
Yes.
Okay.
Yeah, but I have to ask them that question.
The parent population is almost normal, round shape and nearly symmetrical. Then a sample size n5 will probably be sufficient to assure that X bar will be approximately normally distributed. If the parent population is heavily skewed, then it will require a larger sample size to assure that X bar will be normally distributed. The most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that X bar will be approximately normal distributed. This is not a definitive number, but is a rule of thumb. Okay, that's right. Okay, so what are we looking for?
I'm gonna email him this question.
Okay.
Okay. I know that's the answer. I just don't understand why, so we'll go back to it.
Okay.
Or I'll ask him on my own.
Right.
So if the parent population is almost normal. Okay. I think that rule of thumb is important to note. The sampling size of 30. Did you see that?
Oh, for like the second bullet point or the third bullet point?
It said the rule of thumb, sampling size of 30 is usually enough.
30 is usually enough. What paragraph is that in?
I'm still on screen share. Do you want to look?
Yeah. Oh, that one. Yeah, I read that.
Yeah. Okay.
Ugh.
Okay. Next part.
All right. So. Oh no, where'd my paper go? Ah. Oh noes. I think I lost my paper. I can't blame it on a dog because it's on the computer. I can't say that a dog ate the computer because you'd be able to see it.
Sure.
So I lost my paper.
That sucks.
But I will get it. Aha! Found it. Got it. Ha ha ha.
Next
Found
portion
it.
was that puzzle, or the pieces that we were supposed to cut out.
Oh, the random.org thing?
What? All the annual incomes.
Oh yeah, with the 45,000, 39,500. That one?
Yeah.
Is that what you're talking about? Yeah.
Good night. Good night. Mwah. Yeah, we're gonna have family prayer really quick, okay?
Go for it. Family prayer. Yep. This guy's rolling. Yeah, my online classes consist of people in Idaho, Oregon, and I can't remember what other places. Shoot.
You'll find out.
Yeah, I'll find out soon enough.
She's part of your class.
Yeah, I don't have a laptop of my own, and so I come here to the computers.
Works.
Yeah, I was using those ones in there for time, but then I've discovered these. Like, you know, for these Skype calls or Google Hangouts, I'm just going to use these because they're in the comments area, and it's like not as disruptive.
Yeah.
Yeah, because in the comments, like, you can be loud and everything.
Yeah, you have like all
but-
these groups.
But yeah, and then with that place in there, it's just like, can you keep it down, please? Just with all the homework and stuff. So. Come back.
Yeah. The cute kid, huh?
Yep. You're a good man, Charlie Brown.
What's up?
You're a good man, Charlie Brown.
Yeah. I love saying that to people. Everybody kind of looks at me weird when I say it. Okay. Ready to, what's the next part?
Okay, so it says the directions. These numbers represent the starting salaries in U.S. dollars of recent graduates in finance. Please cut out before the guided practice session. We'll use them for a live experiment. Oh no. I did not print them out. I did not cut them out. I hope that doesn't affect me. Too bad.
What'd you do?
I did nothing. That's the point.
Oh. Okay. Let's start the squares on the following page prior to attending a group preparation. Select 5 at random and compute the sample mean. An alternative to cutting them out is to go to that site.
I got it. I have it. I have that site.
Managers between 1 and 30. Use salaries from. That's a cool site.
Yeah, I already have my numbers too.
Man, have you ever played League of Legends?
League of Legends, I have not.
No. That's what I want to
LOL,
do
as
right
it's
now.
called.
Yeah.
LOL. Laugh out loud.
Yeah, lol.
Haha, lol. We're all
I just
conquerors.
call it League. But that's what I want to do. I want to do that, and then I want to go to sleep.
Nice.
Maybe we can petition that.
If it has something to do with statistics, I think maybe. Actually,
Yeah.
I'm not going to get your hopes up on that. Sorry. I just can't.
Okay. All right. So pick a couple randomly.
I got mine.
I bet you do. 4 or 5. Okay. So you have your 5?
Oh, it was 5? I thought it was supposed to be 30.
It says, yeah,
Is it 5 or 30?
it's 5.
Oh, I am going back to that website to get a new set of numbers. That is not very good.
It sounds nice.
Copy on like that. Ugh. All right. Okay. Now I got my new list. But now I have to delete all these other ones.
Okay.
Just give me a second. All right. So my numbers are 29, 30, 3, 23, 25.
What? Your numbers are what?
My numbers are 29, 30, 3, 23, and 25. There you go.
Okay. I've got 6, 16, 12, 13, and 11.
6, 16, 12, 11, and what else?
13.
15?
13.
Oh, 13. My favorite number.
Is it?
Yeah, I like
I
13.
don't understand having favorite numbers. They're just
Well-
numbers.
Well, it's one of my favorites because I was actually born on that day.
Cool. Okay, so add them all together. That's not what I wanted.
So, okay, we're supposed to add all these together then?
You find the mean.
Okay, so 59, 62. 62 plus 23 would be 85. 85 plus 25 would be 110. Okay, got mine up.
You got your mean?
Not yet. I'm adding up your numbers.
Are we supposed to do each other's?
No, I was just doing that for extra credit, which I don't think I'm going to get.
No. Okay.
24, 36, 52, 58. All right. All right, so I'm supposed to find the mean of 110. That's my number, by the way, that I got.
Okay. My mean is just a sec. 49040.
49.
49,040.
How'd you get that?
I added 45,000 together with 44,300, 57,800, 52,800, and 5,300. I added all those together, and then I divided them by 5.
What?
You're supposed to calculate the mean. What'd you do?
I just put numbers in. Yeah, I just put them in.
Put them into what?
I put them into Excel.
Just 1 second.
All right.
Hey, Sam, I'll call you back, okay? I'm doing homework. What?
Okay.
You wrote them into what?
I just put them in. I put them into an Excel program,
Yeah, and then what?
and then nothing else.
Oh, okay, so You'll calculate the mean. So you put the numbers in. You put the number. Okay. Your problem is you put in the number square, not the wage earned. Does that make sense?
Nope, which is probably why I did it wrong.
Okay, so what were your numbers?
29, 30, 3, 23, 25.
Okay, and they correspond with, and look at, so you got to look back at that wage chart, remember?
Okay, wage chart. I'm looking at it. So,
Okay.
29 would be like 29,000?
Yeah, so that's what you're supposed to do.
Oh, okay.
Take the wages.
So 29,000 plus 30,000 plus 3,000 plus 47, right, plus 23,000 plus 25,000.
Uh-huh.
So you get 110,000 then.
Okay, and then divided by 5.
Okay. So 1, 1, 0, 1, 2, 3, divided by 5. 22,000 is my mean.
Okay, cool. Okay, so let's use my mean just for the sake of the assignment.
Okay.
49,040. Now, mine falls pretty close. Okay, so it says illustrate the sampling distribution of the sample mean. Drawn 5 at a time. This group represents the distribution of all possible salaries or samples. Mark a sample on the horizontal axis to indicate the value of your sample mean from part A. So mine was roughly 49. So actually, what's yours again? Say it again.
Mine was 22,000. What is the mean of your sample? Mine would be 22,000. Yes. Awesome. I'm on track again.
Dude, yours isn't even on the chart.
What? It's supposed to be on the chart? I thought it was supposed
Where
to.
are you looking?
I'm looking at my own numbers. I thought you were. I was like giving
I'm
an
doing share
example.
screen again, okay?
Like seriously, I thought that was like an example or something, and I chose from those 5 or whatever.
Okay, so you did your random.org, right?
Yeah, I did that.
Generate. We're gonna do 5
Right.
between 1 and 30, right?
Yep. 1 and 30.
Okay, I got 24, 23, 3, 14, and 14.
Okay, so before we do anything, I interpreted that to mean like 24,000, 23,000, 3,000, 14,000, 14,000. That's what I did.
Okay, but say that again.
So I pretty much added the thousands to the single digits that you did, like the
No.
numbers that you got.
No. Look at the assignment. Look at the chart. Are you looking at my paper?
Yeah.
Do you see what I'm looking at?
Yeah.
So tell me what your numbers were again.
So my numbers were 29, 30, 3, 29, no, wait, 23, and 25. Oh.
First off, it was supposed to be 1 to 20.
I got
We
it.
made a mistake of doing that part.
Okay. I got what you're saying now. I got it. I've been corrected.
Good. Okay.
All right. Shoot.
It's kind of funny.
Yeah, it is pretty funny because I had no idea what I was talking about, and then you came in and corrected me, which was just awesome. Okay.
Do you have it again?
Okay, so I'll do this again. So I have box 29, which is 45,000. Box 30.
I put it in the drawer so you can get it.
Box 3.
I'm gonna get some water. I'll be right back.
All right, I'll do this while you're doing that. 3. Awesome, we got it this time.
All right.
All right, I got it.
Good.
Yeah.
Sure.
Yep. So I added up all my numbers, and then I divided it by 5, and I got 46,120.
You like my cup?
Let's see. Oh. Where'd you get it, Venice?
It's just a massive bottle of water. Or, yeah, it was like it's from Trader Joe's. Okay.
Oh, nice.
Okay. So what does it mean?
My main was 46,120.
Okay, that's better.
Thank you.
Yeah.
I have
The
been
first time you
corrected
said it was
in
like
the correct manner.
2,000, and I was like, that can't be. That's not possible. Okay.
How did you get that? You did something wrong. I just did the numbers. Whatever.
So, is yours normal? Yours is certainly normal.
Mine is normal.
Mine is a little bit right
Oh
skewed.
yeah, it is normal. Yeah, it's like right in the middle.
Yours is like good center.
Yay!
Mine's 4,800. Mine's just a little bit to the right.
You must be a right-handed person.
Ah. Mine's approximately normal.
Approximately normal, but mine is normal.
That's right.
Don't mind my
Same thing
swelled
said
head.
about ourselves. I'm approximately normal. Okay.
Okay. Does your sample appear to be unusual? Explain why you think it is or is not. Is mine unusual? Probably not. Because it's in the center?
We just had this conversation.
Oh, shoot.
That's what we're just talking about.
Oh,
Okay.
just explain it to me one more time.
It's okay. No, yours is normal because it's right in the middle.
Yeah.
Mine's approximately normal because it's just to the right. I think. So we can't compare it to 3 other individuals because we don't have 3 other individuals. So I'm going to take another sample of 5.
Yeah, it's just us.
And
Oh,
then
so
you
we have
do
to
this.
take another sample of 5?
Yeah.
Okay, going again.
Okay.
1.
You can do it quietly though.
Fine.
Okay. Finish?
Yep.
What's yours?
Oh, I didn't add them all up yet.
Oh.
I can finish getting them written down.
I should go into finances. Their starting salary is higher than my finishing salary.
Shoot. Okay, so I got 51, 720.
Okay.
Are we
Wait,
supposed to do this 3 times?
that's fine. What'd you say your mean was?
51, 720.
31?
No, 50. Like 5.
51. Okay. Okay, yours is not usual.
Yeah, I'm a special person. Yeah, let's avoid that topic.
What do you notice in practice when we get to see the means from the samples you draw? Any other means mean that could have occurred? So most of them fit right within that first standard deviation. Only one of them falls outside of it. That's kind of cool. Okay, next part.
The graduate management
Let's go on to the homework because we're running out of time.
Okay. Group meeting. So is it group meeting or homework?
Group meeting.
Thank you.
Yep.
Start. Drew on both of them. When taking samples of N5, what was the shape of the distribution of means histogram when the parent population is right skewed? I think it's normal. What do you think?
When taking samples of 5,
Wait,
one was the distribution of means histogram. What was the shape of the distribution histogram? Isn't it skewed right? I mean, isn't that?
yeah, that's why I said hold on a minute because I imported a thing wrong,
Uh-huh.
and so I'm doing it again.
What are you doing?
I'm just doing the sampling distributions. I'm probably doing it wrong. I don't know. It looks normal though. What do you think?
Yeah, that looks. I mean, but it's to the shape is normal, but it's to the right on that chart.
Wait, what is your n equals?
Mine is 5.
Minus 5 as well. So just making sure. Why do we have a bottom?
Yeah, more or less if it's normal. Huh. I guess it's
So
normal.
is it skewed right or is it normal?
Skewed normal.
Skewed normal. Okay.
Unless I'm wrong. Unless I don't understand. Taking
I
samples
don't
of
think you can skew it normal.
Hey,
Alright.
sample 5. Clear. Hold on. So what'd you get for 4?
4. I thought we were still on number 3. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? Oh,
It's still normal.
yes.
Same with 4.
When the and 5, what was the shape of the distribution of means? Histogram when the parent was normally distributed. Let's see, distributed, uniform, normal. Am I right or am I wrong?
I don't know.
Shoot, I'm done for.
Then mean equals 5. What was the shape of the distribution of means histogram with the parent? It's normal. It's always
Yay!
normal. It's always
Yay!
normal if the parent population is normal. I don't know
Okay.
why. Okay. 6. When taking samples of of uh, huh, of what? The heck is that? Of a point? Of a comma?
That is custom. Looks like.
When n equals 100, what was the shape of the distribution of mean system? Normal. This
All right.
gotta be wrong, right? Am I?
Or the future's just messing with us.
It's always normal when the population is normal, and then it's normal when the size is big enough. Okay, so I'm going back to number 3, and I'm saying skewed right because the sample sizes are 5, and so it's not 30, so it's not big enough. But for number 5, the sample size is 5, but the population was normally distributed, so it should still be okay. All right, I'm going down to
7.
7.
When
When
would the
would the
distribution?
distribution of means be normally distributed? She's all correct. When data are drawn from
Top
okay,
2?
when data is drawn from a normal. Okay, top 2, yeah. Data are drawn from populations, race views. So top 2 and the bottom one.
Okay. 8. Which of the following gives the best explanation of the central limit theorem? Let's see. If the parent population from which the data are drawn is normally distributed, then the sample mean x will follow a normal distribution. Sounds right. And then for bell-shaped data, approximately 68 of the data will be within 1 standard deviation of the mean, about 1.5% of the data within 2 standard deviations of the mean. Approximately 99.7% of the data will be within 3 standard deviations of the mean. I don't think it's that one. What was it?
What did you think it was?
Well, I just read the first 2, but I think it's the top one of the 2. If the sample size is larger, the sample mean x bar will be close to the population of mean. No, I don't think it's that one. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. So I think it's either A or D.
It's not. Wait. No, because it's about sample size. The central limit and the large numbers both are about sample size. But you're right, it is D. It's about the larger the sampling size, the more the sampling distribution will be approximately normal. I think C is the sample mean will be close to the population mean. I think that's the large numbers law. Okay, so let x be a random variable. The population mean 10, and the standard deviation 6. Suppose the sample size n equals 36 is drawn from this population.
Do you remember the fraction and how it works?
The fraction?
Yeah, the fraction that they gave in the tutorial videos.
I wrote down the formula.
Okay, so 10 over 6, right?
Hold on. So mean of distribution of samples is signified by So
Is it 0.046?
standard deviation mean. Hold on one second. Sample mean is equal to population mean. Sample thing, standard deviation is equal to standard deviation over. So, the sample deviation, or the sample mean, is equal to the population mean. So I think it's 10.
Okay.
What is the standard deviation of the distribution of the sample means? 3 decimal places. So you take standard deviation sample, which is, so we divide the square root of 36, which is 6, by the standard deviation.
Which is also 6.
Is 1, right?
Yeah.
Okay.
Right.
Regardless of the distribution of the population, if the sample size is large and is greater than 30,
I think. Oh, it might be either right skewed or left skewed. What do you think?
It's normal.
Normal?
Yeah. That was the rule of thumb that I was reading to you earlier.
Oh. So what theorem would justify your response? It would be the central limit theorem then.
No, it's a large number. Oh, yeah, you're right.
Okay. You ready to submit?
Yep.
3, 2, 1. A minus. I'm good with it. I kept one of my answers different from yours. That's why I got an A minus. But I'm still good with the score.
You got an A minus?
I did. Like I said, I changed one of my answers. And then I didn't keep the same.
The points are weighted. 1 and 2 are weighted. So I got everything right, but I got a B. I got 85% because I answered no on number 1.
Oh, shoot.
Because part of personal preparation is that we're supposed to do part 2, and I didn't do part 2 yet. We're supposed to do part 2 before we meet in groups and then go over our answers.
Well, wait a second. I thought we were supposed to do part 1 before we met. And then part 2 as a team.
See, if you look at that's what it says on the paper. But on his iLearn thing, yeah, if that's the case, then I should have answered yes. But on his iLearn individual preparation, it says work through step 3. Work through the problems of part 3 and the preparation assignment, and check your answers using the answer key. So I didn't do step 3. I watched the videos and I read the most of that chapter. Do you see what I'm saying?
No.
No. Okay. All right. Click on here. I'll do share screen again.
All right.
Okay. Do you see it now?
Yeah, I see it.
Activity directions. Step 3 of individual preparation.
Yeah, like.
So I didn't do it.
Well, I thought it was just like a general, like you work together as a team with part 2. I thought the rule applied like every time.
Oh. I thought we had to do part 2 and then check the answers, and then we're supposed to go over it in group. Maybe I'm wrong. It doesn't matter. It's not that big a deal. Just a few points.
Just a few points. Just a few points. Those few points that keep you from graduating.
Well, I already graduated, man.
Well, you
All right.
stop from getting a bachelor's.
What'd you say?
You can stop me from getting a bachelor's.
Okay. All right, man. I'll talk to you soon.
All right.
It's fun.
Okay, see ya.